In this video, let us continue to do more problems based on complex numbers. Alright, here we've got a problem which reads like this. It says, if x plus iy equals square root of a plus ib divided by c plus id, prove that x square plus y square the whole square equals a square plus b square divided by c square plus d square. Well, if you do remember, this problem is not very different from the one that we've solved in the previous video, except that the question is a little different. The question is kind of direct. It doesn't kind of tell us what the mid step is. But in the previous problem, if you noticed, it told us not only that we have to prove that x square plus y square whole square equals to a square plus b square divided by c square plus d square, but it also told us we need to prove something that happens in between these two steps. That is nothing but we have to show that x minus iy equals square root of a minus ib divided by c minus id, which is nothing but taking conjugates on both the sides. So that's the only difference. So let's start solving this problem and see what happens. So the first step is x plus iy, we're just writing down whatever is given, equals to square root of a plus ib divided by c plus id. So what we have to do here is take conjugates on both the sides. So taking conjugates on both sides, we have x plus iy bar or dash or whatever that is, and equal to square root of a plus ib divided by c plus id. Use a bracket to indicate that the conjugate applies to the entire thing. Alright, so next step is just changing of signs of I. So you have x minus iy equal to a minus ib divided by c minus id under a square root. Alright, so this is what you've got here. So the next step, consider this is equation 1, consider this is equation 2. Multiply 1 and 2 now, that's all. So it's going to be x plus iy times x minus iy equals square root of a plus ib divided by c plus id times square root of a minus ib divided by c minus id. Alright, so the next step is just simple multiplication. It's not even multiplication, but usage of the algebraic identity a plus b times a minus b, which is a square minus b square. So you get x square minus I square y square equal to, now this is going to be simple multiplication. If you're wondering with the square roots what do we have to do, it's like this. If you have square root 2 into square root 3, it is equal to square root of 6, right? You can straight away multiply the numbers inside. So same way, it's going to be a square minus I square b square divided by c square minus I square d square under the square root. So now we know that I square is -1. So -1 into negative is going to be +1. So it's going to be x square plus y square equal to, again, it's going to be the same thing. It's going to be a square plus b square divided by c square plus d square under square root. Because I square is going to be -1 and -1 times negative is positive. Same thing here, alright? Now what we have to do to get to this is nothing but square both the sides. So squaring both the sides, we get x square plus y square the whole square. And when you square a root, the root disappears, right? So yeah, that's going to be equal to a square plus b square divided by c square plus d square. So hence we proved what has to be proved in this problem. So that ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on complex numbers.